Alright, we've got our first section on simultaneous equations, the method of substitution. We'll also take a look at how we would solve them graphically, because you've got a graphics calculator, so you should be checking all of these rather than checking the back of the book. Get in the habit of using your graphics calculator to help find the solution and check if your working was correct. I hope you enjoy that little cartoon there. It's also slightly relevant as we have roughly 6 weeks to go until your exam, so this will be important to you, at least in the near future. So what are we doing when we solve linear simultaneous equations? Simultaneous means to happen together or at the same time. Equations implies there's more than one. So we take two linear equations and we find where they intersect. You can see in the little example on the left there, as long as the lines aren't parallel in 2 dimensions, they are going to intersect. And that place where they intersect is called the simultaneous solution to the two equations. Usually we'll just refer to it as the solution, but simultaneous solution is a nice way of describing it. And so our solution will end up with an x coordinate and a y coordinate. It's very important you remember to find both of those. A lot of people in the exam find the x or the y and then stop. Don't give away marks when you know what you're doing. Sometimes there won't be a point of intersection. You can see there with parallel lines, no point of intersection. They're parallel, they've got the same gradient, and they're not going to meet. Or, the example they didn't show there, they're in exactly the same place. Parallel lines in exactly the same place intersect everywhere. Not particularly useful or challenging when we're doing maths with them, but it's important to be aware that that could happen. What does the substitution method involve? Well, it involves taking one of the variables and making it the subject of one of the equations and then substituting that expression into the other one. We're going to do it algebraically in a second, but let's look at their example and see what happens so we know what we're looking for when we do it. So we'll have a look at solving it graphically with Desmos, and then we'll see when we do the algebra if we get the right answer. So I've already prepared it over here in Desmos. You can see the two equations, y equals 3x plus 2, x equals 3y minus 1, and you can see the point of intersection in Desmos. If you just click on the point, it will automatically give you the coordinates, which is great. Negative 0.625 and 0.125, negative 5/8 and 1/8 if you're like me and you like your vulgar fractions. Will we get the same answer algebraically? We better go ahead and find out. To keep your working organised and neat, why is that not scrolling down when I tell it to? That's going to make it a little bit difficult. I'll find it. Oh, there we go. Then it jumps all the way down. Let's get that back to where we want it. Ignoring that bit on the left, that's just a simple example. Let's use this example they've given us up the top here. Keep your work organised. Label your equations. Make it easy for your teachers to give you marks. That's what you really want to do. If you make it easy for us to give you marks, you're going to be rewarded. If you scribble all over the place and don't work in a nice logical fashion, it's going to be hard for us to award you marks. Number 2 there, x equals 3y minus 1. You can see here, both equations are set up for substitution, so it doesn't really matter which way I go. I'm going to go with substituting the expression in 1 into number 2. So I'm going to say sub for substitute, 3x plus 2 equals y into equation 2. Therefore, equation 2 becomes, and see how it's nice and clear what working I'm doing, make it easy for someone to give you the marks. So wherever there was a y, I'm replacing it with 3x plus 2. Remember, when substituting into an equation, please use brackets when you make that substitution. You'll be much more likely to get the right answer. From here, it's just a matter of solving a simple equation. Let's expand that bracket. 9x plus 6 minus 1. I'm going to get all my x's on one side, everything else on the other. That just involves subtracting 9x. So I'll have negative 8x equals, and I've got 6 minus 1 is 5. Dividing through by 8, and I get negative 5/8, which matches up perfectly with the negative 0.625 that we had when we did it on Desmos. Am I going to stop there? Of course not. We said we need to find the coordinates, not just the x coordinate. Once I've got my solution for x, what am I going to do? I'm going to substitute it into either of the equations that we started with to find the y value. In this case, the first equation seems logical because it's a y equals equation. So I'm going to say substitute x equals negative 5/8 into equation 1. So equation 1 becomes y equals 3 by negative 5/8 plus 2. Y equals negative 15/8, and 2 would be 16/8. So y equals 1/8. Therefore, the point of intersection, or the simultaneous solution, is negative 5/8, 1/8. Reminder, check back at Desmos, negative 5/8, positive 1/8. We got what we wanted. Time for you to try some.